How do IPv6 prefix links define subnets? Imagine trying to organize a huge library where each book has a unique code. The code tells you exactly where the book belongs and how to find it quickly. That's similar to how internet addresses work, especially with IPv6. Today, we're going to see how prefix links help define subnets in IPv6 addresses. IPv6 addresses are 128 bits long, which is a lot of space for unique addresses. To make sense of all these bits, we use prefix lengths. Think of prefix lengths as a way to split the address into two parts, the network part and the host part. The network part tells devices where to find the network, and the host part identifies individual devices within that network. We write these prefix lengths in a notation called CIDR, which stands for Classless Interdomain Routing. It uses a slash followed by a number. For example, in an address like 2001, DB8, 3C4D, 15, /64, the 64 means the first 64 bits are for the network. The remaining 64 bits are for devices or hosts within that network. Most IPv6 networks use a 64 prefix length. This means the network is made up of the first 64 bits, and the last 64 bits are for individual device addresses. This standard makes it easier for devices to automatically set their addresses without extra configuration. It also simplifies routing because routers know exactly how to handle addresses with a 64 prefix. Now let's look at how subnetting works with IPv6. Usually, the first 48 bits are assigned to a site or organization by an internet registry. These bits are called the site prefix. Then, the next 16 bits are used for subnetting within that site. That leaves 64 bits for device addresses. For example, if an organization gets a 48 prefix like 2001, DB81, /48, it can create many subnets by changing the next 16 bits. Each subnet will be a 64 like 2001, DB810, /64 or 2001, DB811, /64. This allows for thousands of subnets within one organization. Changing the prefix length changes how many devices or subnets you can have. A shorter prefix like 48 means fewer subnets but larger networks. A longer prefix, such as 64, means smaller subnets with fewer devices but more subnets overall. This flexibility helps network designers plan for growth and efficiency. Unlike IPv4, which uses subnet masks written as for numbers, IPv6 uses prefix lengths for simplicity. This makes it easier to understand and manage large networks. The fixed 64 size is popular because it supports modern networking features like automatic address configuration and efficient routing. In practical terms, prefix lengths tell routers and devices which part of an address refers to the network and which part refers to a specific device. This division helps traffic find its way across the internet and within local networks. It also helps internet service providers, data centers, and content delivery networks organize and allocate IP addresses effectively. So, in summary, IPv6 prefix lengths define subnets by telling us how many bits of the address are used for the network. This division makes hierarchical addressing possible, supports efficient routing, and allows for large-scale subnetting. It's a key part of how the internet manages billions of devices today.